day, everyone. Um, Welcome to the vMotion application notification presentation. Uh, Today, we are going to be discussing a new feature of vMotion in vMotion on vSphere, and we're going to address what is it, why we're talking about it, and how do you use it. I have a bunch of my colleagues here with me who are going to go through this explanation of what vMotion application notification entails. I have others. We're going to also have a couple of demos showcasing how to practically implement this feature. On that note, I want to start by introducing my colleagues. Ellen, please, over to you. Ellen. Ellen, can you hear me? Can anybody hear me?
I can hear you, Deji.
Yeah, I can hear you. Cool. So I'll just introduce myself quickly. I'm Ellen May. I'm a product manager on bca-help focused on workload mobility and vMotion.
Thank you. Oleg.
Hi, I'm Oleg. I'm a software engineer on the vMotion team, and I work on vMotion application notifications.
Charles.
Hi, I'm Charles Lee. I'm a technical marketing engineer, and I work with business critical applications and modern applications.
And Dharmesh.
I am Dharmesh. I work with Charles and similar role.
And my name is Deji Akomolafe. I'm very happy speaking with you this morning. I am the practice lead for Microsoft Application Virtualization. I work on the same thing with Dharmesh and Charles. What is vMotion application notification? Why is it necessary? Ellen is going to take us through the necessity and the rationale behind this new enhancement to vMotion, which everybody is already aware of. And she's going to describe at a very high level why it's necessary. And our colleague Oleg is going to take us through a deep dive, a technical deep dive of how to enable application notification. Charles and I are going to take you through practical implementation of this feature on both Linux and Microsoft application environment. So here is our call to action for you. We're talking to you today because we want everybody to know about this new, very nifty and useful improvement to vMotion. We want you to test it. We want you to use it. We want you to talk about it. And we want you to help us improve it by providing feedback. And you can always get your feedback to us by emailing us at bca-help@broadcom.com. Thank you very much. Ellen, please take it from here.
Thanks, Deji. So, hi everyone. As I said, I'm Ellen May, a product manager on bca focused on workload mobility. And in this session, I would like to introduce the vMotion application notification feature, go over what it is, what problems it solves, and give a high-level overview of the mechanism. And then I'll hand it over to Oleg and Charles and Deji to give more details about how you can actually utilize that feature. So what is vMotion application notification? It's a feature that ensures that when a vMotion is initiated, the vMotion is paused while a notification is passed to the application, and the application has time to prepare before the vMotion occurs. You might be wondering why an application would need to know about a vMotion. So let me is not aware of a vMotion operation, and the operation is minimally disruptive to the application. For a vMotion operation, our downtime SLA is 1 second, and this is tolerated by most applications. However, there are a class of highly sensitive applications that cannot handle the downtime and will not tolerate the drop in throughput for even a second or a few milliseconds. So when a vMotion happens, these applications either fail or go into some sort of undesired state. As a result, vMotion must be deactivated entirely for these workloads. vMotion notification feature was developed to support the class of highly latency-sensitive applications. Now, by utilizing the vMotion notification, an application can know when a vMotion is going to occur and take necessary steps to handle that impact. And the application will be able to delay the vMotion until it's prepared for it. To elaborate on the use cases for vMotion app notification, I'll go over some example applications. Times could cause unacceptable dead space in audio transmission or even call drops. In the 911 app, if the 911 app had the opportunity to react to a vMotion, the call could be rerouted to another node for the duration of the vMotion, and the impact could be averted. Or the vMotion could even be delayed until the ongoing 911 call is completed. Another example could be cluster database applications that are typically designed for high availability and use heartbeats to detect other instances in the cluster. vMotion downtime here may cause a node to look like it is unresponsive, which could lead to an expensive failover process. So then how can we prevent this? vMotion notification here could allow the application a chance to tune its timeouts to a larger value temporarily for the duration of the vMotion, or drain all outstanding transactions on the node that is going to be vMotion run with a quiesce node for the duration of the vMotion. Likewise, you can imagine how the other example use cases given here could benefit from the ability to avert vMotion downtime impact. vMotion app notification has been available since vSphere 8.0, so if any of these or similar use cases are applicable to you, consider giving the feature a try. Now, let me give an overview of the architecture and how this feature works at a very high level. So here we have the vCenter, the ESXi host, and the VM and VMX host, which is the process associated with the VM, and the guest OS with the app running in the guest OS. So the first step is when the vMotion starts from the vCenter, the app is notified of the vMotion start. So it goes from vCenter, ESX, and then through the VMX, it communicates with the app. And this happens before the vMotion actually starts in the ESX data plane. So at the application to acknowledge the notification. Note that the vMotion delay can be configured to a specific time frame. Now that the application has received the notification, it can run any necessary steps to prepare for the vMotion impact. Once the app is finished preparing, it will send an acknowledged start for the vMotion, and the vMotion will then proceed. Note that if the application does not send an acknowledged start within the vMotion's configured time window, the vMotion would go ahead anyway, so it will not be hanging forever. And once the vMotion ends, the application is notified again so that it can roll back any steps it took to prepare for the vMotion. So that's the basics of the mechanism, and next I'll go over the feature workflow. First, the app must register for notification. Since not all apps need to know about vMotion, the feature is deactivated by default and needs to be configured for an application. Later, Oleg will go over how to do that, but basically, if of the vMotion delay. I mentioned that the vMotion delay time would be communicated to the app at registration time so that the app knows how long it gets to prepare for the vMotion. Now the application will start polling for vMotion start and end events. If there is no event, the hypervisor returns none. And if there is an event, the hypervisor generates a start and vMotion pauses there. The vMotion will then wait for the app to pick up and acknowledge the event. Now the app sees the vMotion start event, picks it up, prepares itself for the event, and then sends an acknowledged start event back. Once vMotion proceeds and completes, it will generate an end event that gets picked up by the app, and the app can now roll back the steps it took to prepare for vMotion. So that's the holistic workflow and a high-level overview of the feature. And in the next section, Oleg will dive into technical details and how to actually use the feature.
Hi. Let me walk you through 3 different scenarios of using the feature. First, we'll go through the simplest one, how to enable vMotion application notification on a virtual machine. Then second scenario is how you can keep track of vMotion start and end times. And finally, we'll look at how you can configure your application to prepare for vMotions. In the first scenario, all we're going to do is enable notifications. We're not going to do any scripts or timeouts. All you have to do is run this Python script. And really, it's just about this one line of code where you reconfigure the VM to enable notifications set to true. The rest of the code is just boilerplate. And let me walk you through it real quick. First, you use Smart Connect to authenticate. You get a service instance back. From that service instance, you get the list of virtual machines running on the host. And you iterate over that list, pick the virtual machine you're interested in, reconfigure, wait for the task to finish, and you're done. What that accomplishes is not only notifications are enabled on the VM, but also this VM would be excluded from implicit DRS operations, such as load balancing. So VM would not be moved behind the scenes, but explicit DRS operations, such as putting host in maintenance mode, are not affected. Next, let's look how you can keep track of start and end times of each vMotion. And for that, we would need to write a custom script. You can write it in any language you like, and that script would be executed in the guest operating system on your VM. Here is the pseudocode for this script. First, you call register and get a token back. And then in a loop, you call check for event. You give it the token. And if you get a stacked event, you log it. And if you get the end event, you also log it. So instead of calling APIs for register and check for event, you would be issuing vmtools-d commands. And this is the syntax for vmtools-d command to register. You give it an application name, which doesn't really matter. And you give it notification type, which is always SLA miss. And what you get back is a JSON response that looks like this. Most important part of it is a token. You need to save this token in a variable. When you register behind the scenes, we create an event queue, and all the vMotion-related events, such as stack and end, start going into that queue. And that queue is not very large. What you see on the screen is literally the size of this queue. And newer events would push older events out of the queue. So you shouldn't wait too long before checking for events. Here is how you check for event. You basically just give it a token. And most of the time, result of that would be this basically empty JSON. But once somebody queues a vMotion, next time you check for event, you'll get a stacked event. In that stacked event, you'll get operation ID. And this is what you can log. And then vMotion would eventually proceed. When VM is successfully running on the destination, you would get an end event also with the same operation ID. You can log it as well. This is how you can log vMotion starts and ends. Now, let's talk about a more complicated scenario, how you actually prepare an application for vMotions. And you already know how to enable vMotion notifications on the VM. You would write a slightly different custom script, and later we'll talk about setting host and VM timeouts. Two things you'll be doing in the custom script is you need to prepare for vMotion, and then you need to be able to restore the normal state once the vMotion is done. And basically, prepare for vMotion is just transitioning a VM from its normal state that doesn't tolerate stuns to a somewhat degraded state that does tolerate stuns. And what this means is different for every application. Sometimes that means that you need to shut down your application. Sometimes you need to fail it over to a different node. It really is up to you. And when you restore the normal state, also it's really up to the application. Sometimes you stacked it back up. Sometimes there's really nothing to do. So it all depends on the application. And the script that you run is very similar to the one we had before. Again, you register, you get the token back, you check for event in the loop, give it a token every time. And the difference is when you get a stacked event, you need to prepare for vMotion. And when you're done preparing, you need to acknowledge that you're done by providing a token and an operation ID. And when you receive an end event, then you need to restore the normal state. Here is the syntax for the acknowledgement event. You give it a token and an operation ID. And now let's talk about timeouts. So you need to set timeouts on your VM and also on the source and destination host. And it's a good practice to set the same timeout value on every host in the cluster. So here is how you set notification timeout on the VM. It's really no different on how you enable VM for application notifications. The only difference is it's a slightly different config spec. Instead of setting notification enable to true, you set notification timeout to the value you passed in from the command line. And setting notification timeout on the host is slightly different. So let me walk you through that. So first you authenticate with Smart Connect, get the service instance. Then from that service instance, you get the data center. From that, you get the host. From the host, you get the option manager. And on the option manager, you update the value of a notification timeout to the value you passed in from the command line. Now let's talk about how you choose the values of timeouts. You want to check for event fairly often. For example, maybe every second, maybe every few seconds. Let's say in this case, you want to check for event every 10 seconds. And it also takes your application some time to prepare. Maybe it's half a minute, but you want to be conservative. So if you set it to, say, 50 seconds, so you add up these two values, 10 seconds and 50 seconds. So your final timeout you set on the VM would be, in this case, 1 minute. And what may sometimes happen is, say, your custom script that calls check for event in the loop, maybe that script got stuck somehow for a few minutes, and in the meantime, vMotion got queued. It waited for 1 minute, timed out, and proceeded, succeeded, and now VM is running on the destination, and only then your script got unstuck, and you check for event. But it's already too late to prepare for vMotion. vMotion already happened. So how can you avoid the situation? So when you get the stacked event, you get the timestamp and timeout shown in blue on this slide. And what you can do is you can make sure that the stack time plus timeout is greater than the current time. Stack time is the number of seconds since January 1st, 1970. Timeout is also in seconds. But how do you get the current time? Well, that depends on what you write your script in and where it runs. Here on the slide, there are examples on how to do it in Linux, how to do it in PowerShell, and if you are if you need to do it in something else, you can just ask ChatGPT, and it would help you with the right syntax. Now let's talk about host level timeout versus VM level timeout. So presumably VM level timeout is set by the app admin, and the host level timeouts are set by VI admin, and they have different incentives. For the app admin probably doesn't want to check for event more than necessary, so the longer the better, and also having more time to prepare is seemingly better. But VI admin has the opposite incentives. For VI admin, like let's say app admin sets the VM timeout to 1 hour. Well, that means that VI admin would need to wait 1 hour before putting host in maintenance mode, and that is obviously not great. So we built some checks and balances into this feature, and first one is that host level timeout acts as an upper bound to the VM level timeout. For example, if VM level timeout is set for an hour, but host level timeout is set for 5 minutes, then effective timeout would only be 5 minutes. But what happens if 5 minutes is still too long and VI admin is getting impatient and wants to set the timeout to 1 second before putting host in maintenance mode? Well, that's not going to work. What's going to happen is next time your script checks for event, you'll get the timeout change event, and you would have up to your original time. If it was an hour, then you get an hour to prepare for this. And this is the last chance you get to prepare. You'll get the old timeout, in this case 20 seconds, new timeout 10 seconds. And if 10 seconds is not enough, maybe you want to shut down your application and or do whatever is appropriate for this situation. So next, Deji.
Yeah, thank you very much, Oleg, and thank you, Ellen. What does all this mean to you as the application owner or the VI admin? Everybody loves vMotion. It's one of the most impressive feature sets in vSphere land. As Ellen has mentioned, over the years we've noticed that some people take the approach of disabling vMotion for their latency-sensitive applications for good reasons, and but they want the high availability and the resource balancing feature of vMotion. vMotion application notification puts the control in an app and VI admin's hand. In the normal operation of vMotion, if you invoke vMotion, vMotion just goes ahead and moves the VM. Now, vMotion application notification puts control of that operation in your hand. What you do with it depends on your use cases. Most applications, most VMs will not need vMotion application notification. And this is why, as Oleg and Ellen mentioned, it's not enabled by default. You have to take proactive action to selectively enable this for your workload. If you determine that your workload requires the extra care and the extra attention necessary to respond to vMotion events before it happens and to intervene in some ways, this is the tool set for you. This is the feature that you've been waiting for. This allows you to enable vMotion capability on all your workloads and avoid the normal implications of the things that happen during that brief timeout when vMotion operation happens. So we are going to go through the process of actually documenting and implementing what Oleg has just so thoroughly described. We're going to show you how to enable vMotion application notification, register for notification from the application, and demonstrate how that workflow happens when a VI admin, for any reason or the other, invokes vMotion operation, how we intercept or trap that call, how we tell vMotion to please take a number, slow down, let's prepare this application and make it stable before you move the VM, and then how we tell the vMotion notification that, okay, we are done, go ahead, and how post the vMotion operation, how we put the application back into production. All right. We are going to start with Charles. We're going to demonstrate this on with a Linux workload. So, Charles. Yoshi.
Absolutely. Thank you. Thank you very much, Deji. So what Dharmesh and I have done is basically take all the good work from Ellen and Oleg and implemented a solution for Linux-based systems. So initially we were working with CockroachDB or Cockroach Labs because it is a very sensitive application. So in their case, like Ellen mentioned, we provide a 1 second SLA, but in the case of CockroachDB, 500 milliseconds is typically too much. So they needed a solution, and the vMotion notification really was able to provide the correct solution to be able to provide the SLAs to CockroachDB. So what is it that we've done? So we've basically created a open source Python 3 application, and we've generalized it to run as a standard Linux systemd service. We've also made our work customizable. So in this particular example, we'll be using CockroachDB, but we've created something that was sufficiently flexible so that a user could customize it to run different commands to accommodate different types of applications, whatever is required. So we will demonstrate, I'll show you exactly what I mean by the customization. So really what this gives users is the ability to run any command that they want before a vMotion and after vMotion. And this is packaged as a well-behaved Linux systemd service. And the reason for this is really providing a generalized tool so that pretty much anyone who has a Linux system that wants to take advantage of the vMotion notification can do so with very minimal effort. So what we provide, it boils down to 5 files. So we have a standard Linux systemd service. We have a script, which is a Python program, which implements the main logic as described by Oleg. We have a configuration file, which is the user configurable file where we can set different things such as the check interval and which is the pre and post command and some other options regarding logging. So we do want to be able to log all of the information, and we do so. And finally, the log file where we basically store all of the information. So as we're checking, as these events occur, we basically log this in a file so that users can then verify and make sure what's going on, or when did the vMotion occur, or what was the sequence of events. So logging is always very important when dealing with these applications. So we do provide very robust logging. So this is our configuration file. So we have the ability to specify the check interval. We can specify the pre-vMotion command. So in this example here, we simply have a ping, just a trivial command. And then as a post-vMotion command, we also have a ping. But this could be replaced with anything. And in the case of CockroachDB, what we're doing is we're simply stopping the node. And then once the vMotion completes, we restart the node. So in the case of CockroachDB, it's better to just stop and restart, and that's what we implement. So in terms of how this looks at a high level, when the users start the vMotion notification service, we first check to see if a token was already registered. And if there is one, we unregister it, and then we proceed to initialize the application again. So we do a cleanup just in case that the application might have crashed or the system was shut down uncleanly. So this gives us kind of a fresh slate. And then we dive into the main loop. And this logic is exactly as described by Oleg. What we do is we simply check to see if there's an impending vMotion event. If there's none, we just sleep for the specified amount of time. But if there is a start, we then execute the pre-vMotion command. And once that completes, we notify the system to proceed with the vMotion. And if the event is a post vMotion command, then we execute whatever user specified command was added to the configuration file to resume normal operation. And because this is a well-behaved Linux systemd service, if the service is stopped by a sigint, sigterm, or sigkill, So if the service is, the vMotion notification service is stopped, we simply stop the service, we kill the main loop, we unregister the token. Now, in terms of the installation, we've also tried to make this as absolutely simple as possible. So we have releases published on our website, on this GitHub repo. And the installation is as simple as downloading a release bundle, extracting the contents, configuring the configuration file, running the installer, and then just validating to make sure that the service is running. And this can be done by checking the actual vMotion notification service and checking the log files to see if it is running and executing, and we're seeing the correct output. So how does this all look with CockroachDB? I will give you a lovely demonstration. All right, perfect. So this is a demonstration of the vMotion notification service running for CockroachDB on a Linux cluster. We'll be using CockroachDB. CockroachDB is a distributed database, and it is latency sensitive. So events like vMotion can impact overall performance. In this case here, we can see that we have a CockroachDB cluster, and this cluster is running 4 nodes. Node 0, Node 1, Node 2, Node 3. And we can see that most of the nodes have been up for over 25 days. And the node where we've been doing some testing has been up for 5 hours. If we look at the metrics, we can see that the cluster is currently running a workload. If we look in vSphere, we can see our 4 nodes represented by these 4 VMs. So node 0, node 1, node 2, and node 3. We can see here that we've defined our service, and it is set to restart always. So if the service, the vMotion notification service fails, it will automatically restart. And we can see here our configuration. So in the case of CockroachDB, what we're simply doing is we're stopping the CockroachDB service prior to a vMotion, and we simply restart it once the vMotion has completed. So very straightforward operation here. So here we can see I have a watch running, and this watch is showing that the CockroachDB service on node 0 is currently active and running. And here we can see I'm doing a tail of the log file. So we can see that the log file is being populated with events. And we can see that these events, in the case of the check, are occurring every second. So 21, 22, 23. So in this case, it's checking and there's no events. So it's simply continuing, looping. So what I'm going to do now is I'm going to select node 0. And I'm going to migrate this to another node at random, somewhat. And I'll try to get this. Okay, so we can see in the log files that the event was received and immediately the service is stopped. We can see in this window right here that the service was stopped and is now restarted. So this occurs automatically and can happen quite quickly. If we go back to CockroachDB and we go to our overview, we can see that all the nodes have been running for 25 days, except node 0, which was restarted just a few seconds ago. And if we look at our metrics, we can see that the workload is continuing in the background as expected. That's it. Thank you very much. And there
Thank
you
you,
go.
Charles.
Very welcome. And thank you very much. And now I'll pass this on to my colleague Deji.
Thank you very much, Charles. And let me. Okay, sorry. That was an excellent demonstration for the Linux workload type. Now we are going to go and demonstrate another use case, this time for Microsoft SQL Server. Uh, we are going to use a clustered instance of Microsoft SQL Server. And the challenges associated with performing vMotion on a clustered SQL Server is most SQL Server instances are production revenue generating workload. Uh, most nodes have at least one active resource hosted on them. And occasionally, there will be a need to relocate one of these nodes to another host, but there's little or no tolerance for outages for these production workloads. We do not want to create unnecessary resource failover. Unfortunately, because clustering SQL is an activity and it's an operation that relies on Windows Server failover clustering, Windows Server failover clustering has a threshold of tolerance for outage, where if one of the nodes is unable to talk to the other nodes, they determine or they decide that they're unavailable, and they try to take over the resources hosted on that host. So host A thinks that host B is not available. It says, okay, host B, node B had all these clustered SQL resources. I need to take it over. In that context, in that scenario, disconnection happens. Queries stop. Um, when you perform a vMotion operation on a clustered Microsoft SQL Server, this has the potential to happen. Normally, we encourage you to increase the timeout, the heartbeat threshold, so to avoid this. Some customers find that impossible or necessary or impractical. Here comes vMotion application notification feature. In this demo, we are going to try to achieve this node relocation, migrate one of these nodes to another host, and we're going to do that without disrupting resource availability. We do not want a timeout to occur. We do not want an unintended resource failover to occur in this demo. We're going to leverage, again, the Windows and SQL Server feature. WSFC, Windows Server Failover Cluster, has the ability to tell a node to to transfer its resources to other nodes in the cluster and to stay out of the cluster for a period of time. Uh, what we are doing, what we are showing here, we want to make it as simple and as repeatable as possible. The tools, the scripts that we used in this demo are all public, just like what my colleague Charles did for the Linux workload. All of these scripts and documentation are publicly available at these links, and you can get raw soft copies of this demo of these slides later if you request it. Now, I am going to also try, in the interest of time, to talk through a recorded video of this demonstration, and I hope it comes through. Let's see. Okay, thank you. I hope you can see this. All right. I'll be pausing this to narrate the experience. This is our cluster, our vSphere cluster. We can see 3 SQL Server VMs in here: SQL 01, 02, and 03. And all of these are participating in a Windows Server failover cluster configuration. Let's go and look at that. Here is the Windows Software Failover Cluster Manager. And here are the 3 nodes up in here: SQL 01, 2, and 3. And they are clustered. They are part of the same WSFC configuration. And also, they performing a role. There's a role that they are hosting, and that role is what you call SQL Availability Group. So there's SQL Server installed on each, they're clustered, and there's an availability group created on them. We're going to take a look at that. This is the SSMS. We're looking at that cluster. We see we have a database that's synchronized across all 3 nodes in here. As you can see, node 02 is the primary node right now. It has active resources. That's this what that indicates. And let me step back a little bit. Sorry. And we have these other 2 nodes, 01 and 03, that are secondary nodes. 3 of them are in the same cluster. Only one of them has active resource. And our demonstration is going to try and vMotion the SQL 02 that has the active resources. And what we expect to see happen is that the vMotion will happen non-disruptively through the facility of application notification. Okay. We have enabled vMotion on we enabled vMotion notification on all 3 nodes. How can you tell really quickly that a VM has been as vMotion application notification enabled? Just look at the VMX file. That's the quickest way for you to tell. So on SQL 03, we've made some very interesting configurations here. On SQL 03, as you can see, we have not enabled app notification. When we don't have app notification enabled, you won't find a key that says vm.app notification. On SQL 01, we have enabled app notification.
Looks like Desh's mic is muted. Oh, it says that your mic is not connected. Yeah, so for everyone watching in the audience, yeah, we were. Let me turn on my camera here. Yeah, while Deji works on the technical issues, yeah, when back when I was a customer, we did have different applications, right? Different applications, different people that owned right that SQL Server, but not only SQL Server and not only databases. We had Linux servers too that were running applications, and it's not that our cluster would constantly vMotion things, but they would vMotion every once in a while, and say a week later we would get a ticket that was opened, and that somebody would ask, and we're like, hey, you know what, this application crashed out of nowhere. Can you see, can you see anywhere in vSphere in your logs to see what happened? And we would go back, like, no, it's just normal operations here, right? And if anything, you kick it down over to the networking team, because it's always the network or DNS. So yeah, when I was looking at the sample exchange, I ran into this, right? So thankfully this team is willing and able, right, to put these awesome things together with these scripts and help people out and just spread the love, right? And share it with the community. So I reached out to Deji because I downloaded the files. Oh man, then I got lost in the files. And I was like, hey, I would love to demo this for the community, because this was a pain point for me. And I'm sure, right? Because we try to practice what we preach. And within the community, if something is a pain point to you, it guaranteed, it is happening to at least 100 other people, maybe 1,000 people. So yeah, so thankfully, this turned into a talk by Deji and the team here. So yeah, so again, I think we have Deji back. So let me
I
hand
think so.
back to
Can
him.
you hear me?
Thank you. Perfect.
All right.
Thank you.
I apologize for the technical glitch. Okay, so as I was mentioning, Oleg mentioned that we had timeout that you could set on the host side and on the client side or the VM side. That's setting that timeout is optional. It just tells the VM, okay, how long to wait. Well, it tells the host how long to wait for the preparation, whatever the admin will set in the guest to finish before continuing with the vMotion. For this one, we've just enabled app notification. We didn't set any timeout. Um, the third VM, we've set both we enabled both notification and set timeout on it to show you what in how you choose to implement app notification, what you choose to implement app notification, what you choose to set or not set. Either way, you have to have application notification enabled for a VM to receive application notification and to be able to respond to it. Okay, now here is the gut of the whole exercise. Again, we do not enable notification by default. It has to be an administrative configuration, and you have to do it only for the VMs that you consider important enough and running latency sensitive application that cannot tolerate vMotion. I will go through some of the configuration some of the things we're doing in this script. However, this is also publicly available and well documented. All right, so let's go quickly. Everything that happens with app notification happens over the VMware tools. So we are using VMware tools to execute the registration, treatment, and all of that. We are checking for 1 second and we are logging everything. This is also optional. You do not have to log. So here is how we enable app notification. We register an application with to receive notification. For our case, this is what we are doing here. Please check every 1 second to see if a vMotion operation is expected to happen or if it's been initiated. And then we go through and we start looking for the event. We start listening. We check for event. We're checking right now. We're not seeing anything. No vMotion operation is triggered. No vMotion operation is pending. Once we see a start of vMotion application notification, what do? This is interesting. This is where the control is. So your VM, your very sensitive VM, has now been notified that a vMotion operation is about to start. There is an application in there that you don't want to disrupt. And and it's called SQL Server, and it's clustered, and we want it to be available throughout the vMotion operation. What do we do? A very small, a very nifty facility exists in WSFC in Windows that says, please suspend this node and drain it. Suspend dash cluster node space dash drain is the only thing we do administratively to respond to that event. We tell WSFC, please make this VM and the SQL that's available on it and all the resources in there, make it available for relocation. What then happens is we hand off that operation to Windows and to WSFC, and WSFC goes and evacuate the resources, and SQL takes this database and move it onto one of the other two nodes that are available in that cluster. And then we go back to watching for events. So suspend cluster node that drain is what we're doing. Then we go back and start looking for actually no. Once we send an acknowledgement back to application notification and say we're done, you can continue with your vMotion. Okay, and we write that to the log as well. And then we go back and listen for notification event, and we look for when app notification tells us that it's ended the vMotion operation, that the VM now is now available. What do? We then invoke again another WSFC command that says, okay, now resume cluster node. Resume cluster node brings that VM, that node back into the cluster and make it available to host resources again, to participate effectively in the cluster. While it's in a drain situation, it's not participating, it's not taking on any workload. So no workload is no resource is going to time out when we vMotion it. No disruption. That is essentially what app notification helps us do. So we resume the cluster node and life is good. Everybody is happy, and we just go back and write things to log. Now we are going to demonstrate a situation where what happens when you don't have application notification enabled, when you're not telling the VM to wait for anything. And then we're going to also show what happens when you have application notification enabled. So for this demonstration, SQL 03 is the one I showed you, the VMX file that doesn't have any indication of application notification being enabled. So we're just going to do a vMotion operation on 03. What you're going to see, it's just going to go ahead. vMotion is just going to go ahead and move the VM. That's what vMotion does, because this VM hasn't registered to receive vMotion application notification. Boom, moves the VM. We say move VM. vMotion says, okay, I'm moving VM. Now, we're going to go into a demonstration of moving of vMotion in the VM that's been registered, has been enabled for vMotion app notification. So 02, like I showed you, was our active or is our active node. It has all the workloads. It has the active workloads. So we are going to go ahead and we're going to now tell vMotion to move it. And we're going to jump back quickly and watch what we are trapping. So see, we received vMotion notification, and we told vMotion, we told WSFC to suspend node and drain it. You can see here that vMotion is waiting. You can see it's not progressing. It's waiting for the VM to say, okay, I'm done. Please move ahead. And once we send that notification back to vMotion notification, you can see that it progresses and tell it to go ahead. It's waiting for us for however much timeout we've configured. So we're done. This is the demonstration. This is causing vMotion operation to take a number and wait for us. One of the things that I didn't show here, that I should have, is how the workload failed over. So remember, we um, just moved the original active node. Now you can see that WSFC moved all the workload to another node, SQL 01, that was available. We didn't have to do anything. We just told WSFC we need this VM to be out of commission for a brief moment. WSFC went and transferred all the loads to another node in the cluster. So now if we do a refresh, our SQL Server connection and everything is still available. The database is still synchronized, and we can still see that there are three nodes, but this time SQL 01 is the primary. 02 is now just a secondary node. It was suspended, it was drained. One of the things that happens that you will see when you look at the scripts is that we do a lot of this, we trap a lot of this through the token that's generated when you register the VM for notification. This token persists through the life of that VM as long as it's running. It doesn't persist after you reboot the VM. So if you say you've enabled the vMotion application notification for your VM, and things are good and it's protected against unintended resource failover, if you then reboot that VM, that registration is gone. So you have to remember to register it. Well, okay, you have thousands of VMs. You can't remember to always go back to a VM and register an application or register with vMotion notification. For now, this implementation, what we're doing here is we're automating the registration of notification. So we put a startup script in a system startup as a task in Windows, and every time we reboot Windows, what happens is that it registers as a service with application notification, and it's not very complicated. It's just the same script that you saw me running in the demo is what we are calling PowerShell to execute. And every time that VM gets rebooted, it will re-register and it will be effectively protected with app notification. That is what we're demonstrating here. It's a PowerShell, and that's the file we're just calling. This is how we persist uh, registration for app notification in Windows. At a later time, it could be a service, it could be other mechanism. But for now, you have to have a way of registering. Here is the log that we keep for every operation. Um, this log is very lightweight, and but you don't have to keep it if you don't need to. This is just for demonstration purposes. Okay. Now, if you have questions, please ask them. Now, this is us now demonstrating that after we've moved to the VM, after we invoke suspend node, after we brought it back into service, is it still functional or did we break anything? So we're just going to go here, normal SQL Server administrative task. We're going to manually fill over the resources from 01. We're going to fill it back to 02 just to be sure that we didn't break 02, SQL 02, when we did whatever we did. And voila, it's now the owner of the resources. And
Deji,
you could go ahead.
we do have a question from Shiva, and
Okay.
it's up here on the screen. They're asking, team, can this vMotion application notification service be used for vMotion triggered using HCX?
vMotion trigger using HCX. So you mean if you're performing a vMotion using HCX, you want HCX to wait Is that the question? If a VM, let's think this through. If a VM is enabled for app notification and it registers properly, and you try to vMotion it outside of vCenter, Oleg, that would be a question for you, really.
Yeah,
We
it should
know,
work. I don't see why it wouldn't work.
yeah. So because it's not a DRS thing, it's actually an active manual operation, and every active manual vMotion operation will trigger that notification if the VM is properly registered. But then what would be the use case in this? You don't want the HCS to continue, or I'm trying to understand
Yeah.
the perspective here. You want to invoke, you want to use HCX to quickly move all your VM. You don't. Okay, so maybe the question is, will it interrupt
Yeah.
an HCX operation? And the answer is yes, because it will wait for however long you tell it to wait
Mm,
before continue with the vMotion.
mm. I would guess this could be something like a data center migration, right? So you're migrating from one data center to another, and you're using HCX. And like Oleg mentioned, I think this should work fine, because what we're doing is we're stretching the fabric, right, using HCX. So the same vMotion principles apply. It's just that we're doing it over a much bigger span, and we're doing it over different data centers. But from a service perspective, we'll get the notification and then we can act upon it. We just have to keep in mind that the durations might be much longer, and we might need to
It
adjust.
it definitely will be longer, which is why then we are asking, is it looking to use vMotion notification to augment or supplement
Mm,
HCX, or is he worried that it may not?
mm,
Yeah, so if you're using HCX to speed up your operation or your migration, I would disable app notification. Get your vMotion, you get your HCX migration done, and then when you get to the other side, you can go and fix things up. You wouldn't want each of the VM that you're migrating with HCS. If this were just one VM or two VMs, you wouldn't be using HCS in the first place.
mm,
But let's say if you're using HCS, we think you have a lot of VMs. Now, if you've registered each VM for notification, each of them will cause a vMotion to wait a considerable amount of time. Uh, so, well, what if you are doing HCX during mass migration? That's not the time to be overly concerned about availability. It usually will be a maintenance window operation. But yes, to answer your question, it will invoke, it will work. Application notification will work. It will just slow down your migration operation, to answer your question directly. Shiva? Okay, I hope we answered Shiva's question.
Perfect. And thank you very much for taking the time to answer it. Yeah, in case they do come back with another comment, I'll make sure to let you know. Thank you.
Thank you. All right, and this brings us to the end of our presentation. Let me stop by here. Uh,
And we have
uh,
another question here. Oh, I'm sorry. I just recognized your name, Charles. Sorry.
okay. Um, Thank you, Frankie, for giving us the opportunity to present this new feature to your audience. We have an ask. of everybody here. This is the first iteration of this feature. This is a major significant improvement to vMotion. Oleg and Ellen and their team would very much appreciate it if you could provide um, your observations, your feedback, improvement, suggestions, everything. Use this feature. Please test it. Talk about it, and definitely please come back to us and tell us what you think of it, what your observations are, how you think we can better improve it, and we like to do what works for you. We like to do what makes you succeed. Uh, this feature is a result of direct requests from customers like you. We would like to know that we met your expectations. So please let us know how you feel, how you see it. Take the tools, the scripts, the sample scripts that we've published both for Windows and for Linux. Adapt it, op modify it, optimize it, but let us know, please. And on that note, I'll go back to Charles, Frankie, Oleg. Anybody has closing remarks, please? Ellen
No,
is
no,
on mute.
yeah, nothing really. This is a really straightforward service. Kind of like vMotion. It's such when you look at vMotion, it's such an incredibly complex process. But we've grown to use it and leverage it. It almost happens automagically in the background, and this vMotion notification can really help applications that are sensitive. So in the case of CockroachDB, we've been dealing with a lot of big financial institutions that leverage CockroachDB, and they love it, right? Great database, and they love vMotion. They love the ability to be able to perform maintenance and migrations. But there was always sort of this gap in terms of, well, it can occasionally lead to service interruptions. So this really fills that gap and provides them with you know reliability and sort of the consistency that it needs, while still being able to preserve all of the operational simplicity that they've come to love and appreciate of vSphere. So it's very, very, very cool.
Well, so with the upcoming VMware Explore event in Las Vegas, will the audience and the community be able to meet you and ask questions there?
Absolutely. Absolutely. We have a session to talk about this. So we'll be very happy to meet people if there's any questions, feedback. We can also be reached via email. So like Deji has posted, feel free to reach out. We're happy to help. We're actively working on this, and always glad to answer any questions.
So Charles and I get paid based on the number of questions that we get, based on the number of emails. So please, if you don't send emails, if you don't ask questions, we starve. You are going to meet us at Explore. Not just meet us, we actually have a wonderful tutorial session, which means we get to show you all of this live, not in recorded video. We have plenty of time to actually demonstrate it and have you follow along. Please register for it. It's who has the anyway, it's vMotion application notification, what, where, and why, or optimizing application availability, something or the other. But it's on the catalog, and I'm the only Deji, so you can't miss me.
And I think the application catalog. I think the content catalog went live today too. So yeah, we will we'll make sure to put a note in the description as well.
All right. If if Ellen, Oleg, and Dharmesh don't have additional input,
for
and if
me,
we don't have
Deji.
okay, thanks, Ellen. Dharmesh,
Yeah,
you
I just
good?
want to echo what Charles said. Yep, that's everything is good here.
Any closing remark?
So anybody else watching this video, right? Yeah, if you're not watching it live, you catch the replay on it. Yeah, definitely. Please reach out. Please reach out to bca-help at broadcom.com to reach out to the team. Can people reach you via LinkedIn and or another social media space, or would you like for them to reach out to this email address to ask you questions?
I'm Dejify, DEJIFY on LinkedIn. I make house calls on LinkedIn, so.
Okay, excellent. Well, thank you very much. Yeah, again, right, this reached. Thank you very much for putting the session together and having the session ready with the demos. Because again, it was an issue that I remember having as a customer, and yeah, thank you very much for taking the time to come up on the VMware Code Power sessions.
It's a pleasure. Thank you for having us.
Thanks, Frankie.
Hasta.
Excellent. Thank you, everyone. And with that, we are done. Thank you.